Yeah, student, in the last lecture we have completed our collision topic. We had already discussed about the elastic collision, inelastic collision, perfectly inelastic collision as well as super elastic collision. And our expression for the elastic collision was that okay, V1 is equal to, it was V1 is equal to M1 minus M2 into U1 plus 2 M2 U2 upon M1 plus M2, and similarly V2 was M2 minus M1 into U2 plus 2 M1 U1 upon M1 plus M2. This was the expression, this was the basically final expression for the elastic collision, as well as we have also studied about the coefficient of restitution, and that was according to the coefficient of restitution we got that key coefficient of restitution in elastic collision was E is equal to 1, and coefficient of restitution means what? Coefficient of restitution means V2 minus V1 upon U1 minus U2. So we have studied in elastic collision that V2 minus V1 were equal to U1 minus U2. That means velocity of separation is equal to velocity of approach. It was okay. Now, in today's lecture, we will discuss about the inelastic collision. That means what will be the formula, what will be the expression if coefficient of restitution will not be equal to 1, and how we will calculate the questions in that case. Okay, if the question is not elastic, then how we can use this formula easily, we will see in today's lecture. Okay, as well as we also discuss some special cases. We will also discuss some special cases related to inelastic collision. Okay, now see, if the collision is inelastic, if the collision is inelastic means coefficient of restitution is not equal to 1. Coefficient of restitution is not equal to 1. In that case, this equation, the velocity of separation and the velocity of approach will be like that, V2 minus V1 will be equal to E means coefficient of restitution multiplied by U1 minus U2. The expression will be like that. And the final velocity of the two particles, that means V1 and V2, can be written like that. V1 is equal to M1 minus EM2 into U1 plus 1 plus E into M2 U2 upon M1 plus M2. Expression will be like that. Okay. If coefficient of restitution will be not equal to 1, then we will use this formula to calculate the final velocity V1 as well as V2. If we will write the formula for V2, this will be M2 minus E into M1 into U2 plus 1 plus E into M1 U1 upon M1 plus M2. This is the basic formula for inelastic collision. Now, by using this concept, we will discuss about some special cases related to inelastic collision in our succeeding lecture. Okay. Now see again. Let it is a case. This is our Earth. Let's say this is Earth. This is the surface of Earth. This is Earth's surface. And an object is just fall from height h. Let an object falls from height h. Let this height is h. And the coefficient of restitution is not equal to 1. Here let's say coefficient of restitution is, let's say, E. And in that case, what will happen with this ball? That means it will go up again. When it will hit the surface, it will go up like this. Again it will come to the surface, again rebounds, again go up, will come to the surface, again rebound, will come to the surface, again rebound and come to the surface, and slowly it will stop. The question is asking related to this is that what will be its final velocity, what will be its velocity after nth collision, how much time it will take in nth rebonding, how much height it will cover in nth rebonding, after the nth rebonding, or as well as how much time it will take to stop. That means slowly it will be stop. So how much total time it will take to stop on the surface, as well as it also question asking that how much distance it will cover during this successive rebonding. Okay, so this question is frequently asked in multiple competitive exam. This question has been asked. So we will discuss what will happen with this body and how we can calculate the final velocity after nth collision, after nth rebonding, how what will time taken by this body in nth rebonding to complete its height, or as well as total distance and total time as well. So in this lecture, how we can study, how we can understand these things, we will see. See, the object just fall from here, so its initial velocity you can say u1 is equal to 0. u1 is equal to 0, and this is the ground, and ground initial velocity is always 0, u2 will be 0, as well as after the collision, when ball will hit at the surface, after the collision there will be no change in the velocity of the ground, there will be no change in the velocity of the earth. So we can also say that v2 will be again 0, v2 will be u2 and v2 both will be 0, and when ball will hit the surface it will go up with some velocity, let's say this velocity is v1, and here it is just coming to the surface, and during the hitting the ground, let's say its velocity is v. And if you want to calculate, if you want to find the relation between this v1 and v, we can easily use this formula that the velocity of separation, that means v2 minus v1 is equal to e into u1 minus u2. So as we have discussed that another particle, another object is our earth, and the initial and the final velocity of earth is 0, so we can say v2 is 0 and u2 is 0, so we can easily say that minus of the v1 will be equal to e into u1. Here negative sign indicates that the initial velocity and the final velocity of the first particle is just opposite. If here the initial velocity is like downward, then the final velocity will be upward. That's why here sign is negative. But if we will take the magnitude, we can easily say, magnitude wise we can easily say that v1 is equal to e into u1. E into u1. Okay. So now let's say here the initial velocity is v and the final velocity after first collision. After, if we will discuss about after first rebounding, we can say what? We can say that this v1 can be written as e into v, where v is the velocity before the first collision, before the first rebounding. The velocity, the initial velocity of the first particle, the ball, initial velocity of the ball is, let's say, v. So we can say v1 is equal to e into v. Similarly, for the next collision, this ball will go up, will attain its maximum height, and again it will come back. When it will come back to the surface, its velocity will be again v1. When it will going up with the velocity of v1, then when it will come to the surface, its velocity will be again v1, and when it will again rebound with the second collision, its final velocity, let's say, v2. So for v2 we can easily say that this v2 can be written as e into v1, or we can say this v2 can be written as e into ev, or we can say this v2 will be equal to e square into v. E square into v. That means after the second rebonding, it's the velocity of the final velocity of the ball will be e square into v. Similarly, after the third collision, it can be written as v3 is equal to e the power 3 into v, and so on, and so on. So we can say we can say कि after nth collision, after nth collision, after nth rebonding, after nth rebonding, we can say the velocity Vn is equal to, we can say easily कि e the power n into v. V is the velocity during the first collision, when ball comes from the height and it just going to touch the ground. At that time the velocity was v, and we can also calculate the v in the term of h. Suppose this was the height h, initial height h, and here u is equal to 0 and ball is just going to touch the ground, and here the velocity is v. So we can calculate the value of v, that is v square minus u square is equal to 2gh, or we can say v is equal to under root of 2gh. So we can write the formula vn is equal to e the power n under root of 2gh, e the power n under root of 2gh. So if we have given the coefficient of restitution and height is also given, then we can calculate the final velocity of the particle after the nth collision. Okay, now let's see one example, one questions related to this formula, then we will discuss the another topic. Okay, हम इसको थोड़ा छोटा कर लेते हैं. How we can minimize this? This is the method. Okay, so I'm just going to small this, minimize this. Now let's say one questions related to this formula. The question is that a ball falls from height 5 meter on the surface having coefficient of restitution, restitution e is equal to 0.2. then find its velocity after third collision, after third rebonding. This is the question. An object is fall from height 5 meter and on the surface whose coefficient of restitution is 0.2, then what will be its velocity after third rebonding? We have to calculate this. Now let's see. Here question is saying that ki height h is equal to 5 meter and the coefficient of restitution e is equal to 0.2, and we want to calculate the v3 मतलब after the third collision. So we have the formula that ki vn is equal to e the power n into v, or we can say vn is equal to e the power n under root of 2gh. This is our expression. So for v3 or for the velocity after the third collision, third rebonding, we can say v3 is equal to e the power 3 under root of 2gh, or we can say कि after third rebonding velocity can be written as e the power 3. E the power 3 means 0.2 the power 3 under root of 2 into g means 10 into height means 5. So this can be written as 0.2 into 0.2 into 0.2 multiply by, this will be 5 to the 10, 10 10 the 100, और 100 square root is again 10. हम यहाँ से ये point को अगर हटाते हैं, this will be cancel out, or we can say this will be 2 to the 4 to the 8 divided by 100, or this can be written as 0.08 meter per second. This will be our velocity. That means when a ball or when an object falls from height 5 meter and it hits the ground whose coefficient of restitution is 0.2, then after first collision it will go up to height this, and then after second collision it will go up to height this, and after third collision it will go up to height this. So question is asking that after third collision what were its velocity, after third collision what will be its velocity, and our answer is after third collision its velocity will be 0.08 meter per second. So by using this simple formula we can easily calculate the velocity of the particle after nth collision. Okay, now we will discuss about the height, that means after nth collision how long it will go up. We can easily see that if particle is coming from here, then after the second rebonding or first rebonding it will not attain the same height, because coefficient of restitution E is not equal to 1. If E will be equal to 1 then it will go up to the same height, but if E is not equal to 1 then it will not attain the same height as it was fall from that height. So that means its height is just reducing after every rebonding, its height is just reducing. So now we will get a formula, we will get an expression for the height of the nth rebonding, for the height after the nth rebonding basically. So now let's see ki height, topic is height attained after nth rebonding. Height attained after nth rebonding. Let's see. We know V1 is equal to what? V1 is equal to e the power n into V. E the power n into V. Or we can say that this V1 can be written as under root of 2g h1 is equal to, here is basically V1, so we can say this will be e the power 1 into V. So under root of 2g h1 can be written as e into under root of 2gh, or by squaring both sides we will get h1 is equal to, or 2g h1 is equal to e square 2gh. 2g will cancel each other, or we can say h1 is equal to e square into h. E square into h. For second collision, after second collision, the final velocity will be v2, or this v2 can be written as e square into v. v2 can be written as e square into v, or v2 can be written as under root of 2g h2. This will be equal to e square into under root of 2g h. Again we will square both sides, we will get 2g h2 is equal to e the power 4 2g h. 2g cancel, or we can say that this h2 will be equal to e the power 4 into h. This is the expression for the height attained by the particle after second rebonding. Now, by seeing these two expressions, we can easily say that after the nth collision, the height hn will be equal to e the power 2n into h. This will be the general expression for the nth rebonding, and after the nth rebonding, the height attained by the particle basically. So this is the expression for the height. Now we will use this formula to calculate the height attained by the particle after nth collision in our next question, and then we will move for the time taken in nth rebonding. Okay. Now let's see. The question is, oh wait. This is our expression. We should just minimize this. See, let's say that is a question. Question is that if an object falls from height let's say 5 meter, from height 5 meter, then find height attained after first rebonding. If coefficient of restitution is 0.3. Question is saying that an object falls from height 5 meter and the coefficient of restitution between the surface and the ball is 0.3, then how much height it will attain after the first rebounding? The question is like that. How we can solve this question? Let's see. Question given that height is 5 meters and the coefficient of restitution E is equal to how much? 0.3, and the number of rebounding is basically first rebounding. So we have the formula Hn is equal to basically e the power 2n into h, or we can say H1 is equal to e the power 2 into 1 into h, or we can say e square into h. When we will put the value of e and h, we will get e basically 0.3, so 0.3 square into h is how much? 5 meter, so it will be 5, so it will be 0.3 into 0.3 into 5, and this will be 100, or 5 3 is 15, 15 3 is 45, so answer will be 0.45 meter. After nth rebonding, that means after first rebonding basically, that means an object just fall from here to the ground, and the coefficient of restitution between earth and the ball is 0.3. Ball just fall to this surface, and after the first rebounding, how long it will go up? Question is asking this. How height it will attain after the first rebounding, and this is basically our h1 and this is basically our h. So this height h will be equal to 0.45 meter if h is basically how much? 5 meter. If an object falls from a height of 5 meter and the coefficient of restitution is 0.3, then after first rebounding it will attain a height of how much? 0.45 meter. This is the answer basically. Now if it will be elastic collision, then how long it will attain the height? How much it will attain the height basically? If there will be elastic collision, then for the elastic collision the coefficient of restitution as small e is basically 1, so we can say Hn is equal to e the power 2n into h, that means 1 the power 2n into h, and this whole will be 1, so we can say after nth rebounding it will attain a height of h. That means if e is equal to 1, if here e is equal to 1, then it will attain the same height as it were have, जो इसके पास जितना पहले था उतना ही height it will attain. Okay, our next expression, our next concept for this rebonding is time taken after nth rebonding. Time taken after nth rebonding. How long it will take after nth rebonding? So how we can solve this this expression, how we can find this expression is, we have the expression that h1 is equal to how much? H1 is equal to e the power 2n into h, e the power 2n into h. And if we want to find out the time, so we can say this h1 can be written as half g t1 square, because u is 0, initial velocity were 0, then if u is 0, then we can say h is equal to ut plus half at square. That means ut will be 0, only half gt square can be written here. So half gt1 square will be equal to e the power 2n into half g t square. Half g will cancel, so we can say this t1 square can be written as e the power 2n into t square. Similar, okay. Here if n is equal to 1, here we are writing here h1, so h1 means n is basically 1, so we can say this t1 square will be equal to e square into t, or we can say this t1 is equal to e into t. E into t. T means the time taken in the first rebonding, in the first collision. Or similarly we can say this t2 will be equal to e square into t, and t3 is equal to e the power 3 into t, and hence we can say tn is equal to e the power n into t. And where t is what? So t is basically object is falling from this height h, this height h. The time taken by this particle to reach the surface for first collision is basically our t. So we can find out this t by applying the formula s is equal to ut plus half at square. Here s is h, u is 0, so we can say this will be half into a is g and t is t square, so we can say this t will be equal to under root of 2h by g. So we can put here the value, or we can say this tn will be equal to e the power n under root of 2h by g. This is the expression for the time taken in nth rebonding. We can easily calculate this, okay. And there will be also some question related to this formula, and we can easily solve by applying this formula. We can easily solve the question, okay. Our next topic is how long it will take to stop. That means if we just drop a ball from height h, drop a ball from height h, it will hits the ground, go up, again come, go up, and so like that. Then how time it will take to stop? To find this time, here let's say in the first rebonding the time is, let's say, t. In second rebonding it will go up, and during going up the time taken is t1, and during coming back it will take again time t1. After second rebonding it will take time t2 to go up, and coming to the surface it will again time t2. And if you want to calculate the total time taken to stop the ball, the expression will be total time t will be equal to first time is t, then plus it will going up and take time t1, and coming back take time t1 again, so it can be written as 2t1 plus after second rebonding the total time taken is 2t2, again फिर 2t3 and so on. This will be the total time taken. Or we can say कि this total time taken can be written as t plus 2 into, we have the expression for the time in the rebonding. That means कि tn is equal to e the power n into t. So for the t1 it can be written as e into t. So we can say here कि t1 can be written as e into t plus 2 into t2 can be written as e square into t plus t3 can be written as 2 into e the power 3 into t, and so on up to infinity. Now if we will take t here plus 2t take common, then it will be e plus e square plus e cube plus and so on. It will be like this. Now we can easily see that this expression is like a geometric expression, okay. This is geometric expression. So we know for the infinite series of geometric expression we have the expression snth is equal to first term a upon 1 minus r. snth is equal to a upon 1 minus r. So we can say total time t will be equal to t plus 2t into, here our first term a is basically e, so we can say E upon 1 minus R, that means 1 minus common ratio. The common ratio between first term and second term is again E, so we can say E upon 1 minus E. So our total time t will be equal to t plus 2t, or we can also solve it easily. We can also solve it like that, t is equal to, if we'll take t taken out, it will be 1 plus 2e upon 1 minus e, or we can say total time t will be equal to t into 1 minus e plus 2e upon 1 minus e, or we can say this total time t is equal to t into 1 minus e, sorry, 1 plus e upon 1 minus e. This will be the expression, or we can say कि this total time t is equal to, our small t is basically under root of 2h by g, so we can say under root of 2h by g into 1 plus e upon 1 minus e. This is the expression for the total time taken by the particle. Okay. Now see again, if the collision is elastic, then what will happen? If the collision is elastic, if this collision is elastic, then how long it will take to stop? How long it will take? Our total time t is equal to capital T under root of 2h by g into 1 plus e upon 1 minus e. If the collision is elastic, if collision is elastic, we can say a small e is equal to 1, coefficient of restitution will be 1, and if coefficient of restitution will be 1, then total time t will be equal to under root of 2h by g into 1 plus 1 upon 1 minus 1, and this whole term will be infinity because 1 minus 1 is 0, so we can say this t will be under root of 2h by g into 2 by 0, or 2 by 0 means infinity, so this will be infinity. That means if the collision is elastic, body will never stop. It will again rebonding back and so on, and it will take time infinity to stop. Okay, but in real life there is no such type of elastic collision. All collision is almost inelastic collision. So we will put the value of coefficient of restitution here between the two surfaces that are colliding, and we can easily calculate the time taken by the particle. Okay, to stop. Okay, now our next topic is, our next slide or next topic is basically how long distance or how much distance body covered before stopping. रुकने से पहले, after, before stopping, how long, how much distance it will cover. So basically the particle is coming from here from height h. It will here will be the first collision or first rebonding, and after first rebonding it will go height up to h1. Again it will come back, it will again cover the h1 height. During coming back it will cover the distance h1, and again go up, again cover the distance h2, and again come back, and similarly it will doing like this, and so on. So if you want to calculate the total height s, yeah, total distance, not height, we can see here total distance. If you want to calculate the total distance s, we can say this s will be written as, first, during first collision the total distance covered is h plus. After first rebonding to the second rebonding, the distance covered is, during going up h1 and during coming back again h1, so we can say h plus 2h1 plus, in second to the third rebonding it will be total distance is 2h2 and so on, like this. Now we can easily say this will be h plus 2 into, for h1 it will be e square into h, plus for h2 2 into e the power 4 into h, plus for 2h3 it will be 2 into e the power 6 into h, and so on, like this. Now here is h plus, we can take 2e square h taking out, this will be 1 plus e square plus e the power 4 plus, and so on, and so on. Okay, now calculating this expression, we will get the final expression s is equal to, that means total distance s is equal to, this will be, sorry, this will be h into 1 plus e square upon 1 minus e square. This will be the expression for the total distance covered. Again, if the collision is elastic, then a small e will be equal to 1, and if a small e will be equal to 1, so 1 minus 1 will be 0, that means this will be the something divided by 0, and if denominator is 0, then this whole term will be infinity. Then it means if a collision is elastic, then the total distance covered by the particle will be infinity. Okay, so this is the basically total topic that is generally asked in generally competitive examination if you are going to write the NEET or the JEE examination basically. So this question is frequently asked, so you must have the formula for the total distance, formula for the total time taken to a stop, formula for the time taken after the nth rebonding or the velocity after nth rebonding, as well as the height attained after the nth rebonding. You must have all this formula. I would like to summarize all these things here, and you should just learn this thing, just remember this thing. That was after nth rebonding, after nth rebonding, after nth rebonding, Vn is equal to e the power n into v, or we can say e the power n into under root of 2gh. First was this. Second was height attained, hn is equal to e the power 2n into h. Third one was time taken, tn is equal to e the power n into t, that can be written as e the power n under root of 2h by g. This was third. And for total distance and total time, total distance, yeah, total time, for total time taken, t is equal to t into 1 plus e upon 1 minus e, or we can say this total time is equal to under root of 2h by g into 1 plus e upon 1 minus e. This will be the total time taken by the particle before coming to rest. Okay, and the total distance, for total distance, if you want to see, for distance covered, total distance, basically total distance covered, we have the formula s is equal to h into 1 plus e square upon 1 minus e square. This will be the expression. So you must learn these formulas, you must keep these formulas in your mind, and this will be very helpful in your competitive exam in doing the question related to inelastic collision especially. Okay, thank you so much.